The automobile is a marvelous piece of machinery in many ways. Consider a Volkswagen being driven from New York to Chicago. During that 16-hour trip, 12,600,000 individual sparks will ignite a fuel-air mixture to drive the pistons. And each of these 12,600,000 sparks must occur at the exact instant it will do the most good. Making sure the firing happens at the precise right time is one of the jobs of the Volkswagen mechanic and the subject of this film strip. Ignition failures and poor ignition performance are the most common and costly source of automobile trouble. Therefore, it will be worthwhile to spend a few minutes to review some of the basic principles of the ignition system. As we know, in the four-stroke cycle engine, each cylinder fires every second revolution of the crankshaft. On the intake stroke, the piston goes down and draws in the fuel-air mixture. On the compression stroke, the piston goes up with both valves closed, and the fuel mixture is compressed. Then comes the spark and the power stroke, as the expanding gases of the burning fuel force the piston down. After the fuel is burned, the piston goes up again in the exhaust stroke, forcing the combustion byproducts out of the now open exhaust valve. Thus, in a Volkswagen, 2 cylinders fire for every crankshaft revolution, and all 4 cylinders fire every 2 revolutions. The job of the ignition system is to assure that sufficient voltage is delivered to the spark plug of the correct cylinder at the exact instant that the piston is in position to make the most efficient use of the burning fuel-air mixture. Naturally, this doesn't just happen. First come years of research, design, and testing by the manufacturer. Then it is the responsibility of the mechanic to follow certain guidelines in making basic adjustments. Then there are certain automatic controls designed into the system, but also checked by the mechanic. These controls change the instant of ignition to meet varying requirements of speed and engine load. We will go into these adjustments and controls in a moment. But first, let's look at the basic ignition system. Here is an ignition circuit with the parts indicated. They are the battery, ignition switch, ignition coil, breaker points, condenser, distributor, and spark plugs. The object of the system is to get the battery to furnish enough voltage to make a spark jump across the gap of the spark plug electrodes. But a modern automobile battery puts out only 12 volts, far too little to cause this to happen. So we have to find a way to increase the voltage many times. The voltage is increased by the coil, working with the breaker points. As the ignition switch is turned on, current flows from the battery through the primary winding of the coil and through the breaker points when they are closed. The points are opened and closed by a cam, which revolves at half crankshaft speed as the engine is turned over. With the points closed, the ignition circuit is completed, and a magnetic field is set up in the primary winding of the coil. Any change in this field will induce a high voltage current in the secondary winding because it has many more turns than the primary. The cam has 4 lobes, one for each cylinder. It is at the end of the distributor drive shaft. which in turn is driven by the engine crankshaft. It is so linked with the crankshaft that each time a piston reaches approximately top dead center of the compression stroke, one of the cam lobes opens the ignition points. When the points open, current stops flowing through the primary winding and the magnetic field suddenly collapses. The magnetic field collapses inwards. As it collapses, it induces a high voltage current in the secondary windings because there are so many more turns in the secondary. The high voltage, as much as 23,000 volts, now goes to the distributor rotor, which is keyed to the breaker cam, so that they operate in synchronization. At the same time the breaker points are open, the rotor is in contact with one of the 4 terminals connected to a spark plug. The current then flows down the center of the plug, jumps the gap between the electrodes to produce a hot spark, and is grounded to the engine block. One very important component in creating the high voltage current which fires the fuel-air mixture is the condenser. The condenser is connected across the ignition breaker points. It has 2 functions. First, as the breaker points open, they tend to arc. This may cause the breaker points to pit or burn. The condenser provides a place for the current to go during the first instant that the breaker points separate, so that it doesn't arc across the opening points. Second, after the points have separated, and there is no longer any danger of an arc, the current that has been stored in the condenser flows back into the coil, opposing the primary magnetic field, which is already collapsing. The faster the field changes, the higher will be the current induced in the secondary. The spark should jump the gap between spark plug electrodes when the appropriate piston is at its firing point in the compression stroke.